Welcome children to the class of mathematics. In this video we are going to see the class 10 mathematics topic polynomial part 2. First content we are seeing about the relationship between the zeros and coefficient of a polynomial and the problems related to the upper topic, and at last formation of a quadratic polynomial when the sum and the product of zeros are given. Now let us start the topic. The first content what we are going to learn here is the relationship between zeros and coefficient of a polynomial. So when we have used the word zeros and coefficient of a polynomial, we are particularly mentioning that we are going to learn here about quadratic polynomial, that is ax square plus bx plus c, where a is not equal to 0. Now let alpha and beta be the zeros of this quadratic polynomial and their relations with the coefficient. Now here what is the coefficient? Coefficient of a quadratic polynomial, it means suppose if ax square plus bx plus c is a quadratic polynomial, then coefficient of x square is a, coefficient of x is b, and constant is c. Repeating once again that coefficient of x is a, whereas coefficient of x square is a, coefficient of x is b, and the constant is c. Now how they are being related to each other? Sum of a zeros means sum means that should be added, that is where we have considered that zeros are alpha and beta, then their sum will be alpha plus beta. That alpha plus beta, how they are related to the coefficients of a polynomial? They are related as minus coefficient of x divided by coefficient of x square, that we have written here, that is minus b by e, that is alpha plus beta is equal to minus b by a. Whereas product of a zeros means where we are multiplying the zeros, we have written here as alpha into beta, and those coefficients are related in this way, that is constant divided by coefficient of x square, that is a, or simply it can be written as alpha into beta is equal to c by a. Now once we have written the relationship between the sum and the product of zeros, now let us verify this relation by taking one of the example in below. Right, first example, that is a quadratic polynomial x square minus 2x minus 8. First we need to find those zeros of this polynomial. For that we need to have this simplification of this polynomial by splitting the middle term, that is minus 2x. When you add the substitute term to the x square, you get minus 8x square. We need the factors of minus 8x square such that when you multiply them you must get minus 8x square. When you sum them you should get minus 2x, and the factors are minus 4x and 2x plus 2x. So in between that we have written here, that is x square minus 4x plus 2x minus 8. Now once we have splitted the middle term, how we can simplify further? Since it has contained the 4 terms, it can be simplified by grouping method. We need to make two groups. In the first group, when we see there, we can have a x as a common, so it can be simplified as x into bracket of x minus 4, whereas in the second group we have 2 as a common, therefore plus 2 into bracket of x minus 4. Now in this expression we can see that x minus 4 is again common, so x minus 4 into bracket of x plus 2. Since we need to find the zeros of this polynomial, so we need to write x minus 4 is equal to 0 and x plus 2 is equal to 0. Therefore when you transpose this to the right hand side, that is minus 4, it becomes x equal to 4, whereas when in case of x minus 2, when you transfer that plus to the right hand side, you get x equal to minus 2. Now we have got the two zeros that of a quadratic polynomial, that is x equal to 4 and x equal to minus 2. Now the first zeros I am going to consider it as alpha, and the second 0 I am going to consider it as beta. So here alpha have considered as 4 and beta have considered as minus 2. Now we have to verify whether this relation is true or not. Let us start now. Here we have finded the zeros, and we need the coefficient of this polynomial, quadratic polynomial, that is x square minus 2x minus 8. Before we have discussed that the coefficient of x square is a, coefficient of x is b, and the constant is c. So when you relate with this quadratic polynomial, in place of ax square, here we have x square. It means the constant polynomial along, so the constant coefficient along with the x square is 1. So here a is equal to 1, whereas the coefficient along with x is minus 2. We have written here, we have written that is b is equal to minus 2. Then c we have told as it is a constant. Here minus 8 minus 8, the c has been written as minus 8. Now let us verify in this sum and product relation. Here, as we have discussed before, that sum is nothing but alpha plus beta is given as a relation of coefficient minus b by a. So we have simplifying these alpha, beta and a, b, c in this equation. That is, alpha plus beta is nothing but alpha is 4, whereas beta is minus 2. We have written as alpha in place of alpha is 4, in the place of beta is minus 2, and whereas when it is minus b by a is equal to minus as it is into bracket, that is into the flower bracket, b it is minus 2, we have written here minus 2, and a is 1 is equal to minus into minus, we get plus, 2 by 1 is 2, right? Here we have retained the 2 as it is. When you simplify the values of alpha and beta, here you get 4 plus into bracket of minus 2 is nothing but plus 2. So here hence verified that is 2 equal to 2, that is the relation of sum and coefficients. Now let us see whether it is applicable to the products. So alpha into beta is equal to c by a, that we have learned earlier. Alpha, here in the place of alpha we have put 4, in the place of beta we have taken minus 2 here. Whereas c by a, c is minus 8, we have written here c, in place of c we have written minus 8, and in place of a, as usual, a is equal to 1, we have retained here. Then when you simplify it, a minus 8 by 1, you get minus 8. Here in LHS place, 4 into minus 2 because of the simplification of alpha and beta. So you get 4 into minus 2 is minus 8, and here minus 8 as it is minus 8. So here the sum of us at zeros and product of zeros has been verified. So this relation has been verified. Now let us see one more example related to the same thing. That is one problem. Find the zeros of a quadratic polynomial and verify the relationship between the zeros and coefficient of this polynomial, that is 3x square minus 12x plus 15, and also also find the values of alpha square and beta square. Solution. Considering this polynomial, that is 3x square minus 12x minus 15, we need to product the absolute term with the x square coefficient, that is 3x square into 15, you get 45x square, 45x square. We need to find the factors of 45x square, so that the product is minus 45x square and the sum is minus 12. So the factors are minus 15x and plus 3x. So once you have been got this thing, we need to have the grouping method, that is these two and another two. From these two we can take 3 has common, 3x has common. So 3x, when you take out common, you get x minus 5. Again in this second group you get 3 has a common, so plus 3 into bracket of x minus 5. After that, when you observe this expression, you have x minus 5 as a common, so when you take out x minus 5 as a common, you will retain with another binomial, that is 3x plus 3. So since we need to find out the zeros, we need to write 3x plus 3 equal to 0 and x minus 5 is equal to 0. So 3x is equal to minus 3. By transposing to that plus 3 to the right hand side, you get minus 3. Then x equal to minus 3 by 3. At last you get x equal to minus 1. Here x minus 5 is equal to 0. When you transport that minus 5 to the right hand side, you get x equal to 5. So one of the zeros we are going to consider it as alpha, that is minus 1. Other zeros, that is beta, is equal to minus 5. Now let us see the coefficients of this quadratic polynomial. In place of x square coefficient, we have a, that is nothing but 3. So a is equal to 3 here. Then coefficient of x, that is b, here we have minus 12. We have written b as minus 12. Then constant is last term, that is absolute term, minus 15, that is c is equal to minus 15 has been written. Then verifying the relations of coefficient and zeros, as we have learned earlier, that is alpha plus beta is equal to minus b by a. So here alpha is minus 1, from here we have got, and beta is 5, we have got from this part. So minus 1 plus 5 is equal to minus b by a is equal to minus, as it is, b is minus 12 we have written, and a is 3, minus 12 by 3. So minus into minus plus, you get 12 by 3 is nothing but 4. So 4 has been written here. Then minus 1 plus 5, you get 4 is equal to 4. Hence we have been verified the sum of the zeros is equal to minus b by a. Then product is alpha into beta is equal to c by a. Alpha is minus 1 we have got from here, and beta is 5, that is from here. Then c by a, c is how much? Minus 15, and a is 3 from here. So minus 15 by 3, you will get minus 5. So minus 1 into 5 is minus 5 by 5 is equal to minus 5. Hence it is verified. So along with that question, it has been asked, that is, find the value of alpha square plus beta square. So alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta. That is, suppose a plus b whole square is equal to, can be written as a square plus b square plus 2ab. So but we need only, that is, a square plus b square, that can be written as a plus b, as I've told before, a plus a square plus b square plus 2ab. In order to cancel that plus 2ab, we needed to write here 2ab, that is minus, in terms of minus 2ab. This minus 2ab and plus 2ab will be cancelled, and you will be retained as a square plus b square. And why we need to write in this form? Why? Because we have here a plus b whole square and 2ab. This is nothing but sum of a zeros, and this is nothing but product of a zeros. So it becomes easier for simplifying this values. Now alpha plus beta whole square is equal to alpha plus beta whole square minus 2 alpha beta. Here alpha plus beta, that alpha plus beta value you have got 4. So here in place of alpha plus beta whole square, we have got 4 square minus 2. 2 has constant here. Into alpha into beta. Alpha into beta you have got minus 5. So here alpha into beta you have written minus 5. 4 square is 16, minus into minus plus, 2 into 5 is 10. So 16 plus 10 is nothing but 26. So therefore the value of alpha square plus beta square is 26. The same value can be found by the another method, that is alpha square plus beta square. When you have got the values of alpha and the beta, just to simplify, the value of alphas here, that is minus 1 whole square plus beta has 5 square minus 1 square is plus 1, 5 square is 25, so 25 plus 1 is 26. The last part of this video, that is formation of a quadratic polynomial when sum and the product of the zeros are given. Suppose if alpha and beta are the zeros of a quadratic polynomial, then the quadratic polynomial can be formed in this way, that is p of x is equal to constant k into flower bracket x square into bracket sum of the zeros into x plus product of the zeros. It can also be written as in mathematically form, that is p of x is equal to constant k into flower bracket of x square minus into bracket alpha plus beta into x plus alpha into beta, or simply we can written as p of x is equal to x square minus into bracket of alpha plus beta into x plus alpha beta. Here we have used the k, that k is nothing but a constant. Here k can be omitted. How we can omit a k? It has been written here, that is values of a polynomial do not depend upon k, that is a constant, because zeros of ax square plus c bx plus c or k into flower bracket of k into bracket of ax square plus bx plus c are same. When you find the zeros, whether it is ax square plus bx plus c or k into flower bracket of ax square plus bx plus c, the zeros are same. Therefore, while writing the polynomial for a given zeros, the constant k can be omitted or left. Now, let us see one more example how we are forming a polynomial when we have sum and product of zeros. Here, find the quadratic polynomial if sum and product of zeros are 1 by 4 and minus 1 respectively. So, sum he has given 1 by 4 and product he has given as minus 1. Sum is nothing but alpha plus beta is equal to 1 by 4, whereas product is equal to alpha into beta is equal to minus 1. So our equation to form a quadratic polynomial is p of x is equal to k into flower bracket x square minus into bracket alpha plus beta into x plus alpha beta. So k into bracket of x square has been written as it is minus alpha plus beta. In place of alpha plus beta, 1 by 4 is been written here, minus into bracket of 1 by 4 into x. In place of alpha into beta, we have replaced by alpha into beta, that is minus 1. K into bracket of x square minus 1 into x, you get x divided by 4 minus 1. Next k, here we are going to find out the LCM of this within the flower bracket. The LCM will be 4. So when you take out the LCM, you get k has outside into bracket 4x square. This should be 4x square. 4x square minus x minus 4 by taking the LCM. So this 4 can be taken outside with the constant, that is k by 4. We are left within the bracket, that is x square minus x minus 4, 4x square minus x minus 4, that can be simply written as 4x square minus x minus 4. As we have said before, that constant k can be omitted while writing the polynomial. Thank you.